All right, welcome back. In this video, we're going to finish section 8.1 by doing just a couple of examples. So we finished all the instruction for this section. Is just about doing some more examples of different types of problems. So that's what we're doing. Let's go ahead and start with this one. We have 2x squared minus 12x plus 18, and it's divided by 3x squared minus 27. And so where we'll start is by factoring the numerator and denominator. So I can see in the top there's already a common factor of 2. So let me pull that out and see what's left. So we'll have 2. That will leave us with x squared minus 6x plus 9. That's a perfect square. So we'll have 2 and then x minus 3 squared. Okay, down below, we again have a common factor of 3. If we factor the 3 out, that will leave us with x squared minus 9. So that is a difference of squares. So that will be 3x plus 3, x minus 3. Okay, putting together the pieces, we'll have 3x plus 3, x minus 3 in the numerator. That came from factoring. Actually, no, that's our bottom. Sorry. Our top was 2x minus 3 times x minus 3. The bottom was 3x plus 3, x minus 3. Sorry about that. So now the common factors of x minus 3 can be divided out of the numerator and denominator. That will leave us with 2x minus 3 in the top and 3, x plus 3 in the bottom. Okay, and so it looks nicer probably to go ahead and multiply that out because there's more simplification that can be done. So we'll have 2x minus 6 in the numerator and then 3x plus 9 in the denominator. Okay, so that will do it. Okay, next up we have in the top a difference of cubes. That's going to be p cubed minus 4 cubed. So you're going to have to remember how to factor that. So factoring a difference of cubes was a binomial times a trinomial. And a binomial is the two things that got difference of the two things that got cubed. So here we'll have p minus 4. Then we'll have p squared. Remember the sign is opposite. So plus 4p plus 16. Okay, down below, this is just a difference of squares. So we will have p plus 4, p minus 4. Okay, so putting together the parts, our numerator was p minus 4, p squared plus 4p plus 16. Down below, we had p plus 4, p minus 4. The p minus 4s are going to divide out, and so we'll be left with p squared plus 4p plus 16 in the numerator and p plus 4 in the denominator. And that's it for that one. In the next one, what's interesting kind of is that the numerator and denominator are actually just opposites of one another. In the top, we have y minus 2. So the y is positive 1 for a coefficient. The 2 has a negative 1, basically, for a coefficient. And the situation is reversed in the denominator. So how to handle this is we're just going to factor a negative out of either the numerator or denominator. I think it's simplest just to factor it out of the numerator. So if I factor a negative 1 out of the numerator, we'd have negative y plus 2 for now. And then down below, still 2 minus y. Okay, so then rearranging the terms inside the parentheses, that will be 2 minus y instead of negative y plus 2. And then a 2 minus y down below. The two common factors of 2 minus y divide out, leaving you with negative 1 over negative 1. Sorry, negative 1 over 1, which is negative 1. In general, whenever you have the numerator and denominator just opposite of each other, then that simplifies to be negative 1. And that's what we had happen here. All right, we're going to see that happen again, don't worry. All right, so here we have 10 minus 2y in the top, y squared minus 25 in the bottom. Take a minute, try this one yourself, pause the video, try it, restart the video, and see how you did. Okay, so up top, there's a common factor of 2, which we'll factor out. That will leave actually 5 minus y in the numerator. And then down below, a difference of squares, we have y squared minus 25. That will be y plus 5, y minus 5. Okay, and then the y minus 5 and 5 minus y are opposites of each other, right? Those two blue highlighted are opposites of each other. So I'm going to do like I did in the previous example with the y minus 2 and factor a negative 1 out. So let's see that now. So we'll have 2, and then I'm factoring out a negative 1. And then 5 minus y will turn into y minus 5. Down below, I won't do anything right now. Okay, make sure that you understand that last step because that was kind of the key step to getting this done. Now the two y minus 5s are going to divide out. And so we'll be left with negative 2 in the numerator and y plus 5 in the denominator. Okay, that's that. We have just one more example and we're all done. Okay, so once again, take a minute, try this one yourself, and then check and see how you did. Okay, up top we have just a quadratic polynomial. We have a lot of practice at factoring those. So this will factor as x minus 5, x plus 1. Once again, remember you can always double check by multiplying that back out. Down below, a difference of squares, we'll have 5 plus x, 5 minus x. I know it looks a little weird to see the variable in the back, but just following the pattern, we'll get 5 plus x, 5 minus x. Okay, so now once again, x minus 5 and 5 minus x are opposites of each other. So I'm going to factor out a negative 1 from the numerator, factor of x minus 5, and that'll turn into 5 minus x. I will still have the x plus 1. Down below, we'll have 5 plus x, 5 minus x. Now the two 5 minus x's will divide out, leaving negative x plus 1 divided by 5 plus x. And then that's it. You can leave it like that. I kind of like to put the negative in front of the entire fraction. I just think it looks a little nicer. And I'm going to turn the 5 plus x into x plus 5 just because I'm used to seeing the variables in the front. But either of these last two is okay. All right, that takes us to the end of section 8.1. Finally, let me know if you have any questions and have a great day.